Hello everyone, I am Mir MD Tasnim Alom, and I hope you already know me. I'm really sorry for not being able to join you in person today because the moment you will be watching me, I'll be traveling to my home country, Bangladesh. Actually, I'll be in an airplane, of course. Um, I extend my gratitude to Dr. Angelica for giving me this wonderful opportunity to present in this format. So without further wasting our time, let's start our presentation. I have Caleb and Ian with me as my teammates, and they'll be presenting in person today. And in our project, we tried to do a comprehensive study of crop practices and soil dynamics at Kellogg Biological Station, Michigan. So this is the objective of our study. We try to see like how different tillage methods and different fertilizers input impact on the corn and soil health. And for this, we measured chlorophyll, nitrogen, and phosphorus amounts in corn leaves. We also measured total organic carbon, nitrates, phosphates, heavy metals in solid and aqueous soil. And then we tried to correlate between them, and also we tried to correlate them, I mean, with the chemical inputs to different farming practices. We did that in our study. So in USA, 50% of its land are used for agriculture, and half of it are used for corn, soybean, and wheat. This is our study site, which is Kellogg Biological Station. It's in Michigan, of course. It's in Kalamazoo County, just between the Grand Rapids and Lansing. So it's a 3.5 hour drive from here, Bowling Green. So we had to like travel 7 hours to go there and come back in a day. It was a hectic day, of course. In the left side image, you can see our study site, LTER main site. LTER means long-term ecological research. That means Kellogg, in that farmland, they have been doing this research for a long time, about 40 years. In the right side image, you can see the layout, plot layouts. There are like many different treatments, T1 to T7, but we only focused on T1, T2, T3, and T4. Those are the 4 treatments that we studied for our study. Each treatment has 6 different replicates. So total 24 plots, which was our study site. So let's know a bit about the Kellogg Biological Station. They started this project in 1980. It's a property of Michigan State University. So the land was donated by Kellogg. Kellogg is like very rich organization. They produce wheats and many grocery things. And the researchers are doing their research and they cultivate corn, soybean, and wheat periodically in T1 to T4. Say if year 1 they cultivate corn, in year 2 they'll cultivate soybean, and year 3 they'll cultivate wheat. So things will go like that. Each treatment has 4 different replicas. That means total 24 parcels, and each parcel means 1 hectare. In 2023, they cultivated corn, so we studied corn for our study. So there are like some details, differences between T1 to T4. In the left side table, you can see in the first column, different plot numbers are being written, T1, T2, T3, and T4. In the next column, the types of corn are being there. For T1 to T3, they use genetically modified corn, which is like the type of seed, corn seed they used. And in T4, they used non-genetically modified corn. In the next column, the mechanical weed control or tillage, you can see in T1, they only used 1 tillage. In T2, they didn't use tillage at all. I mean, they didn't use any mechanical weed control. In T3, they used 3 times of tillage. In T4, 9 times, the highest. In the next column, you can see the fertilizer type, nitrogen, phosphorus, potassium, sulfur, zinc, different types of fertilizers being used in different plots. And for herbicide, which means a kind of pesticide which actually control the growth of weeds, for T1 to T3, they used herbicides, but in T4, they didn't use any herbicide at all. In the right side table, you can see the amount of fertilizers they used in different plots. In T1, they used conventional amount of fertilizers. It got the highest amount of nitrogen fertilizers, which is like 200.25 pound per acre. In T2, they also used conventional amount of fertilizers. That means T1 and T2 are just same. Only difference between them are the number of tillage. T1 got one tillage, but T2 didn't get any tillage at all. In T3, the fertilizer amount got reduced. In T4, further reduced, but we can see the phosphorus and potassium fertilizers are used like heavily in that plot, but the amount of tillage was highest, 9 times for T4. So I don't know. I actually know that you cannot remember this at all. So I have made a summary slide for this. For T1, conventional fertilizers and tillage. T2, conventional fertilizers but no tillage at all. T3, increased tillage but reduced fertilizer. T4, highest tillage and very reduced to none fertilizers. There are some pictures you can see here for our study site. In the number 1 picture, you can see they are planting corn. In the second picture, you can see they are applying fertilizers. Maybe it's potassium. They didn't mention this name in their website. In the T3, in the number 3 image, you can see they are using nitrogen fertilizers, and they use nitrogen fertilizer in this method. In number 4 image, you can see they're using tillage. This is how they control their weed. They call it mechanical weed control. This is the tillage. And number 5 and 6 image, you can see the corns that are in full vigor or in full growth. You can see. So when we went to our study site, we actually saw the corns like that. These are our plots. So for methodology, at first we did sample collection. We collected our corn and soil samples on August 16, 2023. As I said before, each treatment plant has 6 replicates, but we went to only one replicate, which is R1. T1 has R1 to R6 replicates, T2 has the same, T3, T4 has the same. We only went to T1 R1, T2 R1, T3 R1, and T4 R1. R1 to R6 are all the same, but different replicates. So we went to actually 4 plots, T1 R1, T2 R1, T3 R1, and T4 R1. At first, we collected the soil samples with a soil auger, and we collected 3 soil samples from each plot. We went to 4 plots, that means 12 soil samples in total. Then we collected corn leaves, 3 random leaves from one plot, that makes it 12 in total. Then we labeled all the samples carefully, and then we brought these samples to our BGSU lab for further analysis. So this is the methodology that we did. This is the workflow. At first, we did the sample collection, and our samples are divided into 2 parts, leaf and soil samples. The leaf samples, we extracted chlorophyll from the leaves in the field. We did that with a machine called SPAD 502. And in this machine, it uses an infrared light, which actually measures the chlorophyll, and it's very fast method. And it measures the chlorophyll from the field. It gives us an instant result. For nitrogen and phosphorus, we brought the leaves to our chemistry lab, and we did further analysis, and then we extracted the total nitrogen and phosphorus. And for the soil samples, we also subdivided our soil samples in 2 parts, for the solid characterization and for the aqueous characterization. We know this part because about all of us did the same for this part, so I'll not waste much time on explaining this. For solid characterization, we sent our samples to a laboratory, and they gave us the result. And in that solid soil, we got the pH, the cation exchange capacity, the nitrogen phosphate amounts, and different things. And in the aqueous characterization, we extracted nitrogen and phosphorus, then we extracted TOC, and we extracted heavy metals from the aqueous part. Then we collected all the data, all the result, and then we did some correlation and statistic analysis, and we tried to interpret, like, if you use this amount of tillage or this amount of fertilizers, what amount of nitrogen and phosphate you will get. What is the relation between different tillage and different fertilizers with different amount of chlorophyll, phosphorus, heavy metals, and etc. kind of things. So in our study, we did that in our result portion. So that's all my part. Thank you guys again for watching this video. If you like this video, I don't know, you can follow me, subscribe me, or whatever you want to do. I'd love to call my next presenter to continue this presentation in person. Thank you.